Alright, so this last example is going to be another one where I will have to use substitution to solve. Right? I cannot solve it with a matrix. And I can kind of look at my equation and see that I've got a cube here. Alright, so that means I'm going to have a square term with the quadratic, not linear, can't use a matrix. Alright, though, before we do that, we have to set it up. Alright, so Joe's got a mowing service. He's found that it takes him about, again, so these are based on averages, 6 hours to mow a large lawn and 3 hours to mow a small lawn. Alright, they have a total of 450 hours available to mow lawns each month. Alright, Joe wants to use all of those hours. He estimates that if he mows X large lawns and Y small lawns per month, this is a profit equation. Alright, so the constraint has to do with the number of hours, right? And so it takes 6 hours to mow large lawns, which is our X variable, 3 hours to mow small, which is our Y variable, less than or equal to, but I'm going to write equal to. It is going to be an equal to in this case. Remember, we rewrite that as 6x plus 3y minus 450 equals 0, because that's what we plug into our Lagrange equation. Alright, so Lagrange, first thing we do is we plug our profit in. So negative 2x cubed plus 1830x minus 6y squared minus 120y plus 60000 minus Lagrange times the constraint. Alright, take our first order derivatives. So negative 6x squared plus 1830 minus lambda times 6 that equal to 0, f sub y, 0 out, negative 12y minus 120 minus lambda times 3 equals 0, and then again, our lambda is negative 1 times 6x plus 3y minus our 450 equals 0, which, remember, that can always be rewritten as the constraint equation, which I'm going to hold off on that, and what we're going to do is what we did when I did this example using the labor cost example before. Now this one's going to be a little different because, again, it's more quadratic equations, but the idea is the same. The first thing we're going to do is we're going to solve both of these for lambda. All right, it's the same setup as what I talked about in the previous case. So I'm going to take my first equation, solve it for lambda, my second equation, solve it for lambda. All right, so I'm going to do that here. So negative 6x squared plus 1830. And I'm going to go ahead and add the 6 lambda to the other side. So I'm going to get 6 lambda over here. And then divide out by my 6. And remember, when I divide every term. So this is going to be x squared, 1,800, so 305. Negative x squared from my negative. 305 equals lambda. Right, then I'm going to do the same thing for the second equation. Again, I'm going to add the 3 lambda to the other side. So when I go write it down here, I'm going to do that. So I get negative 12y minus 120 equals 3 lambda. Divide everything by 3. So I get negative 4y minus 40 equals lambda. Alright, so I've solved my 2 equations for lambda, and so now we're going to set them equal to each other. Basically, I'm doing a substitution. I'm substituting the expression for lambda. So over here, and I'm actually going to do my work down here. I'm going to kind of move my work down here. I have my negative x squared plus my 305 equals negative 4y minus 40. So now I've got an equation where I've got x's and y's. I'm also going to bring down my constraint equation. So my next equation is 6x plus 3y equals 450. All right, so there. Now I've got my system of 2 equations with 2 variables, right? Both of them have x's and y's. And so again, often it's going to be the constraint equation is going to be the easier one. Not always, because when I did the Kobe-Dobb example, it wasn't the case. But with these cases, it's often easier to solve for one of my variables here. And actually, I'm going to solve for y, because if you look over here, I've got my x squared. And so it's easier to substitute out y. So I'm going to solve this one for y. So I'm going to move my 6x to the other side. So I've got 3y equals 450 minus 6x, divide everything by 3, and so I get y equals, well, 150 minus 2x. Alright, so that's what y equals, and so that's what I'm going to go in and plug in here. And make sure you're careful. When you go plug it in there for y, I take the entire expression, 150 minus 2x, and multiply it by negative 4. Alright, so I've got negative x squared plus 305 equals negative 4 times 150 minus 2x minus 40. And then you just solve. So this is going to be a quadratic. So first thing I'm going to do is simplify and then move everything to one side to set it equal to 0. Alright, so distribute your negative 4 here. So negative 4 times 150 comes out negative 600. That's a 2. So positive 8x minus 40. So I've got 8x minus 640. And then I'm going to move these over here. So I'm going to add my x squared and minus my 305. I'm going to set it equal to 0. I get my x squared minus 305. And so on this side I'm left with 0. X squared plus 8x minus 945. Alright, then it's a quadratic set equal to 0. So you can solve it with the quadratic formula. You can graph it, find its zeros, use the box method, the AC method. This one actually factors, so I'm going to factor it. Alright, factors of what multiplies to give me 945 and adds to give me 8. Well, factors, as it turns out, is 35 minus 27. If you take 35 times a negative 27, you get negative 945. And when you add them, the difference is 8. Alright, so that means I have two answers. I've got x equals 35, negative 35, and x equals positive 27. Remember what we're talking about, though. These are lawns, right? I can't mow a negative lawn, so that one doesn't make any sense to the application. Alright, so that's the only one that makes sense. X is 27, so to find y, I've got to plug my 27 in here. So I take my 150 minus 2 times 27, and y comes out to be, when I do that, 96. Alright, so that means, in order to optimize their profit, they've got to mow 27 small or large lawns, 96 small lawns. And then to find the profit, you plug the 27 and the 96 into the profit equation. So you go back all the way to the original profit equation, and this is where you're going to plug your 27 and your 96 in. Again, just make sure you're very careful. This is where I make my mistakes. It's just mistyping something when I plug it into my, miss a negative or a number or something. When I do, hopefully you get the same thing. I get 3,228 is my optimum weekly profit when they mow 27 lawns that are large and 96 lawns that are small. Alright, so that's it. We're done. That's the last piece of information for the semester. Alright, so make sure you look it over and understand and prepare for the test and the final. Alright, all done.